This is Space Time, Series 21, Episode 39. Coming up on Space Time, another 6 months before the federal government decides on a home for Australia's new space agency, the maiden flight for the newest version of the Falcon 9, and Robonaut 2, that humanoid robot sent to work on the space station back in 2011, returns to Earth after failing to power up in orbit. All that and more coming up on Space Time.
Welcome to Space Time with Stuart Gary.
A new phase in a project to search the heavens for signs of extraterrestrial intelligence has just commenced at the CSIRO's Parkes Radio Telescope. The Breakthrough Listen project, funded by Russian physicist Yuri Milner and the late British cosmologist Stephen Hawking, has installed new digital instrumentation on the 64-metre dish in rural central western New South Wales. The upgrades will allow scientists to record higher data rates from the Parkes multi-beam receiver. The previous receivers used by the Breakthrough Listen project only observed a single point in the sky at a time and were used to perform a detailed search of stars within just a few light years of the Sun for evidence of extraterrestrial technology. The new multi-beam receiver has 13 beams, enabling a fast survey of large areas of the sky, surveying millions of stars across vast areas of the galactic plane and central bulge of the Milky Way over the next 60 days. The bulge is the galactic centre and one of the densest neighbourhoods in the galaxy. At the heart of this region is Sagittarius A star, a supermassive black hole some 4.3 million times the mass of our Sun, and it's surrounded by tens of millions of stars within just a few light years. While this chaotic environment probably isn't well suited for the emergence of life as we know it, the region surveyed by Breakthrough Listen covers a huge slice of the Milky Way, containing tens of billions of stars, including many that lie between us and the galaxy's heart. The new digital instrumentation installed by scientists and engineers from the University of California, Berkeley and the SETI Research Center expands on the existing Breakthrough Listen backend so that it can now handle 130 gigabytes per second, thousands of times the bandwidth of even the best home internet connections. This represents over 100 million radio channels scanned for each of the 13 beams, making it one of the most comprehensive SETI experiments ever carried out. Overall, the Breakthrough Listen survey will commit Parkes to some 1,500 hours of observations during 2018, resulting in raw data volumes totaling more than 100 petabytes. This is Space Time. I'm Stuart Gary. It'll be another 6 months before the federal government decides on a location for Australia's new space agency. The South Australian capital Adelaide was seen as a front-runner because of the state's long history of spaceflight and defence technology developments thanks to the Woomera rocket range in the far north of the state and the Australian Submarine Corporation in Port Adelaide. However, Sydney's new so-called Aerotropolis, which is being established around its soon-to-be-built second international airport at Badgerys Creek, is being suggested as a more appropriate location. New South Wales Premier Gladys Berejiklian is lobbying the federal government for the new space agency, claiming Sydney is the nation's technology capital. It's already headquarters for the Australian Astronomical Observatory, and the state is host to the Siding Spring Observatory, as well as the CSIRO Parkes Radio Telescope, the Narrabri Radio Telescope Compact Array, and the Molonglo Radio Telescope Facility. The Federal Innovations Minister Michaela Cash says the new agency will formally start work on July 1st. The yet-to-be-named space agency will be headed for its first year of operations by former CSIRO boss Megan Clark, who says the national capital, Canberra, is actually shaping up as early favourite for the agency's headquarters. The Australian space industry is currently worth just $4 billion annually. However, establishment of a formal space agency is expected to quickly triple that to at least $12 billion, generating 20,000 high-paying high-tech jobs in the process. To find out more, Andrew Dunkley is speaking with Dr. Fred Watson from the Australian Astronomical Observatory.
Budget news. Dun, dun, dun.
Yeah, who would have thought that we would have been celebrating the budget? But we are.
Not many people do.
No, that's right. The 2018 federal budget contains what's being described as seed funding for the new Australian Space Agency. You and I have talked about the Space Agency before, and we've probably said more than we should on what it might be called, whether it's ASA or it's not like NASA. And there are other acronyms that people have suggested.
Yes, there were a few real rippers. Not fit for broadcast.
That's right. So, yes, we've talked about it before, but it's now a reality, Andrew.
Well, Shazza was a good one. Shazza was a really good one. Very Aussie.
The Shazza, the Southern Hemisphere one.
Yeah.
So what's the story? Well, the government is going to put $50 million into the new space agency. We also now know that the director for the first year will be the former boss of the CSIRO, Dr. Megan Clark. She has basically been charged, or she was charged last year, with undertaking a review of Australian space activities with the idea of pulling all this together under the umbrella of the Space Agency. And to some extent, her review was upstaged because they announced the review last July. And in September, they said, well, we're going to have the Space Agency anyway. But now what's happened is that the announcement has been made. We know much more about what the structure of the Space Agency might be. What we don't know is where it's going to be yet. A number of states have put their hands up to host the new space agency. In some ways, that doesn't matter because when you're dealing with space, the whole world is part and parcel of it.
Yep.
But of course, there are centres of activity within Australia, and actually South Australia is one of them. There's a lot of space work goes on down there. So,
well, historically, it's where we really started our space program in Woomera.
With Woomera, that's absolutely right. So there's all that tradition. There's new ideas. There's new industries. There's new space enterprise going on, all of which will now come under the overall umbrella of the new space agency. But the thing that is, I think, really promising is what we might earn from this, because we in Australia currently generate round about $4 billion worth of activity in the space industry, and that covers everything from communications to building little CubeSats and all the rest of it. That is about 1% of the current global market for space activity. So it's round about $400 billion. But there's now a forecast that within 3 decades, so perhaps the next 30 years, that space industry is expected to be worth more than $3.5 trillion US dollars. So it's on its way up. It's a big ticket item, and we are going to be well placed in Australia to be part and parcel of that, along, of course, with all the other national space agencies around the world. I mean, we're never going to be a NASA, but we will always work with them, and the Japanese space agencies, and, of course, now the New Zealand Space Agency as well. So we've got a twin not very far away.
Yeah, and how much was the budget figure?
50 million.
Which is just about Fred's salary. And that is it. All gone.
Dreams in your dreams. It's actually, I have to say, Andrew, it is more than I expected it to be. I thought it was going to be less than that. So it's a nice surprise.
That's Dr. Fred Watson from the Australian Astronomical Observatory, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. Okay, time now to take a break from the show and hear a word from our sponsor, Grammarly. If you write anything on the web, you'll become a big fan of Grammarly's. Their intelligent program will save you time and time again. Built by linguists and language lovers, Grammarly's writing app finds and corrects hundreds of complex writing errors, so you don't have to. You can easily copy and paste any English text into Grammarly's online text editor, or just install Grammarly's free browser extension for Chrome, Safari and Firefox. Grammarly's algorithms flag potential issues in the text and suggests context-specific corrections for grammar, spelling and vocabulary. Grammarly explains the reason behind each correction, so you can make an informed decision about whether and how to correct an issue. Grammarly helps you write mistake-free on Gmail, Facebook, Twitter, LinkedIn, and nearly anywhere else you write on the web. And for Spacetime listeners, Grammarly's offering a free download of the Grammarly software. To download Grammarly today, go to getgrammarly.com/spacetime. That's www.getgrammarly.com/spacetime so they know you came from us. And we'll include the link in the show notes as well. And now, it's back to our show. SpaceX has successfully carried out the maiden flight of its new Falcon 9 full-thrust Block 5 launch vehicle, the same rocket which will eventually be taking astronauts to the International Space Station, possibly by the end of the year. And that's something which hasn't happened from American soil since July the 8th, 2011, when the Space Shuttle Atlantis blasted off on its historic final mission on STS-135. This latest Block 5 version of the 70-metre-tall Falcon 9 provides greater thrust, increased structural strength, improved systems redundancy, and increased reuse capabilities, allowing each core stage to be launched up to 10 times between major rebuilds. The mission blasted off from the Kennedy Space Center's Launch Complex 39A at the Cape Canaveral Air Force Base in Florida, carrying Bangladesh's first telecommunications satellite, the Bangabandhu 1, into geostationary transfer orbit. The launch had been delayed several days after an onboard computer triggered a launch abort shutdown just a minute before liftoff.
Falcon 9 is at flight pressures.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition, liftoff.
Falcon 9 liftoff at 4:14 p.m. Eastern. At T+10 seconds, the thrust vector control system
vehicle is supersonic.
Tilted Falcon to begin a pitch kick maneuver to get it going sideways. You just heard that we're going supersonic and we're about to go through max Q when the rocket's pushing hardest against the atmosphere.
Vehicle is experiencing maximum dynamic pressure.
We've successfully achieved that major milestone of every rocket launch. We're actually decreasing the thrust in our engines a little bit around the time of max Q to minimize some of those forces.
And back engine chill.
There will be 3 events in quick succession. The main engines will cut off, the 2 stages will separate, and the second stage will start its Merlin vacuum engine, which you heard is just beginning its own chill procedure.
Pico.
Those events occurring just as planned. The next major event is the fairing deploy coming up just a few seconds from now.
Fuel is on nominal trajectory.
The fairing's falling way behind. They're light, they're made of carbon fiber and aluminum honeycomb, but they still represent excess mass, so we no longer need them once we get out of the atmosphere.
Acquisition of signal per minute.
We had 3 events in rapid succession. We had a main engine cutoff from that first stage, we had a stage separation event, and then we had a second stage light, followed quickly then by a fairing separation. Everything's going great right now. Falcon 9 is looking pretty good. Those titanium grid fins, they slowly deployed just after stage separation. And those grid fins will allow the Falcon 9 first stage to guide itself back down towards the drone ship. Of course, I still love you. Brief flashes of those cold gas thrusters as they guide provide additional control authority for that first stage. That Merlin vacuum engine is glowing red hot with those exhaust gases as it propels Bangabandhu Satellite 1 into its final geostationary transfer orbit.
After deploying the Falcon 9 upper stage, the new Block 5 core stage conducted a successful landing on the SpaceX drone ship, Of Course I Still Love You, which was stationed 630 kilometers downrange in the North Atlantic Ocean east of Cape Canaveral.
Our Falcon 9 first stage today is going to perform 2 burn maneuvers in order to get back down towards the drone ship. The first burn is going to be an entry burn. There's the startup of the entry burn. At this point, the Falcon 9 first stage is actually only about 10% of the mass that it was on the pad. So it's actually pretty empty of fuel and liquid oxygen right now. So this entry burn is only going to last a few more seconds before cutting off. Again, that second stage is still continuously propelling Bangabandhu Satellite 1 into orbit. One thing that is unique about this mission is that the second stage engine cutoff is going to happen just before the landing. The second stage engine cutoff and landing are right on top of each other, so be prepared for those 2 events to happen in quick succession. But we do have confirmation that the landing burn has started. Those landing legs should be deploying very soon. There it is.
It was the 25th successful landing of a Falcon 9 core stage and the 14th at sea. 11 of those recovered core stages have so far been refurbished and reused. The 3,750-kilogram Bangabandhu 1 was deployed 33 minutes after launch. The spacecraft then began using its own onboard engines to convert its highly elongated transfer orbit into a circular 35,706-kilometre high geostationary orbit. The Thales Alenia-built space satellite is equipped with 26 Ku-band and 14 C-band transponders, providing telecommunications, television and data relay services for the Bangladesh Telecommunications Regulatory Commission for the next 15 years. The flight was the 9th SpaceX launch so far this year. The company expects to more than double last year's 18 missions before the end of the year. Meanwhile, SpaceX engineers are now inspecting the inaugural Block 5 core stage, taking it apart to see just how it survived its first launch and landing cycle. SpaceX designed the Block 5 to be capable of undertaking 2 orbital launches within 24 hours. Eventually, SpaceX hopes to reuse the new first stage at least 10 times between major refurbishments, with plans to ultimately fly each core hundreds of times, and that means cycles similar to commercial airliners. The Block 5 is also the last major upgrade of the Falcon 9 before the introduction in the next decade of the new BFR, or Big Falcon rocket, in case you were wondering what that meant. Right now, SpaceX are planning on building between 30 and 50 Block 5 core stages, depending on demand, meaning the Hawthorne, California-based company is expecting at least 300 more Falcon 9 launches before the BFR takes over the majority of the manifest. The Falcon 9 Block 5 also addresses NASA's human rating requirements needed before astronauts can start flying aboard the new Dragon 2 crew capsule on missions to the International Space Station. NASA demands 40% higher stress ratings for structural components compared to those set for satellite launches. The Falcon 9 Block 5's avionics have also been upgraded, with increased redundancy to cope in the event of multiple systems failures. New flight computers, new engine controllers, and a more advanced inertial management system have also been incorporated into the new launch vehicle. The 9 first-stage Merlin 1D engines used on the Block 5 have also been upgraded, now developing some 190,000 pounds of thrust per engine. That's 8% higher than the Block 4 full-thrust engines. The upper stage's single Merlin 1D vacuum engine now develops 220,000 pounds of thrust on the Block 5. That's up from 210,000 on the Block 4, although it was throttled back to 210,000 for this mission. The Merlin engines have also been equipped with new upgraded turbopump turbine wheels to prevent cracking, and new helium pressurization tanks that won't be susceptible to the frozen liquid oxygen pooling issue, which led to that spectacular Falcon 9 pre-launch failure in 2016. The Octaweb structure, which holds the 9 core stage engines in place at the bottom of the rocket, has now also been improved with higher strength aluminum and increased thermal protection. Also, the structure is now bolted rather than welded onto the rocket. The Block 5 also uses a new hydrophobic thermal protection system on the core stage, the interchange, the raceway, and the landing legs in order to better deal with atmospheric re-entry temperatures. The old composite heat shield near the engine section has now also been replaced with a stronger titanium structure that's been fitted with an active water cooling system to better withstand re-entry temperatures. The landing legs are now also using a new internal locking system in place of the older mechanism, making them easier to reset after deployment. Other improvements, including new reusable steerable payload fairings and titanium steering grid fins in place of the older aluminum ones, have already been phased in over the last couple of years. NASA will require at least 7 successful flights of the Block 5 before approving the Falcon 9 for manned spaceflight. The Dragon 2 is slated to undertake its first test flight in August, with the first manned test flight to the space station expected by the end of the year and regular crew transfer missions to the space station beginning in 2019. Meanwhile, Boeing's CST-100 Starliner space station crew transfer vehicle will initially fly on the Atlas V, which is already man-rated. You're listening to Space Time. I'm Stuart Gary. Astronomers have discovered their first carbon-rich asteroid in the Kuiper Belt, the cold outer rim of the solar system. The Kuiper Belt is a region of frozen worlds, comets and icy debris circling the Sun out beyond the orbit of Neptune. The findings, reported in the astrophysical journal Letters, support some models of planetary migration during the tempestuous early history of the solar system. The unusual Kuiper Belt object, which has been catalogued as 2004 EW95, is a 300-kilometre wide carbon-rich relic of the primordial solar system. The study's lead author, Tom Segal from Queen's University in Belfast, was able to determine the composition of this anomalous Kuiper Belt object using the European Southern Observatory's Very Large Telescope, or VLT, in Chile. The observations suggest that this curious object, discovered some 4 billion kilometres away, most likely formed in the much closer asteroid belt between Mars and Jupiter, and was then flung billions of kilometres from its origin to its current home in the Kuiper Belt. Theoretical models, known as the Grand Tack hypothesis and the Nice model, predict that after the gas giants Jupiter and Saturn formed some 4.6 billion years ago, they began a planetary migration inwards, triggering the formation of the terrestrial planets Mercury, Venus, Earth, Mars, as well as the hypothetical planet Theia, which collided with the Earth a few million years later to form the Moon. As they rampaged through the inner solar system, Jupiter and Saturn ejected small rocky bodies along their path into far-flung orbits in the Kuiper Belt and Oort cloud, great distances from the Sun. Carbonaceous asteroids such as 2004 EW95 would be among the inner solar system's rocky bodies that were flung out there. Eventually, Jupiter and Saturn migrated outwards again to their present orbital positions, in the process disrupting the orbits of the ice giants Neptune and Uranus, causing them to swap their orbital positions, and possibly also flinging a third ice giant out of the solar system completely, or at least to the outer reaches of the Kuiper Belt, where it possibly resides today as the yet-to-be-discovered but much-hinted Planet 9. The peculiar nature of 2004 EW95 first came to light during routine observations with the Hubble Space Telescope by Wesley Fraser, also from Queen's University. He noticed that the specific patterns of wavelengths of light or spectra being reflected from this object were different to that of similar-sized Kuiper Belt objects, which typically have uninteresting featureless spectra that reveal little information about their composition. Segal says the reflective spectrum of 2004 EW95 was clearly distinct from the other observed outer solar system objects, and appeared to be enough of a weirdo to be worth a closer look. The asteroid's dark carbon-rich surface provided a demanding scientific challenge in the velvet black of deep space. However, two features in the spectra did stick out: the presence of ferric oxides and phyllosilicates, neither of which have ever been seen in Kuiper Belt objects before, and strongly pointed to this asteroid having originated within the inner solar system. This is Space Time. I'm Stuart Gary. Robonaut 2, that humanoid robot sent to work on the International Space Station back in 2011, has returned to Earth after failing to power up in orbit. The Stig-like robot was a passenger aboard the SpaceX Dragon CRS-14 cargo ship, which returned to Earth splashing down right on target in the North Pacific Ocean off the coast of Baja, California. The return to Earth had been delayed by a few days due to rough seas forecast for the recovery zone. The Dragon CRS-14 had launched from Cape Canaveral on a Falcon 9 rocket back on April the 2nd, rendezvousing and docking with the space station's Harmony module 2 days later. The capsule was carrying 2,640 kilograms of experiments, equipment and supplies for the Expedition 55-56 crew on station. For its return journey to Earth 31 days later, the Dragon was loaded with some 1,900 kilograms of completed experiments and equipment, including a metabolic microgravity therapeutics drug study, the APEX-06 study on growing seed grasses in microgravity as a future food source on long-duration missions, the Fruit Fly 03 experiment looking at immunity responses in microgravity, and a bunch of astronaut mice who have been helping scientists find drug delivery systems for combating muscular atrophy in microgravity. Also returning aboard CRS-14 was Robonaut 2, that humanoid Stig-like robot sent up in 2011 aboard STS-133, the final flight of the Space Shuttle Discovery. We haven't heard much about Robonaut 2 since its deployment. It was designed to be a bit like, well, think of the Jetsons' robotic maid Rosie, but with less attitude. It would undertake various daily workload duties such as cleaning, thereby allowing crews to concentrate on more important tasks. It was meant to be a permanent member of the space station, but for some reason it was unable to power up in orbit. Despite efforts to troubleshoot the problem on station using Robonaut 2's twin back on the ground, the issue couldn't be resolved, suggesting some sort of electrical glitch. Although others suggested it simply didn't want to be a cleaner on the space station. Anyway, it was then packed away for a long time and almost forgotten until space was finally made available on the return flight of CRS-14. Once repaired, Robonaut 2 will be returned to the space station to continue with its duties. The next resupply mission to the space station will be the launch of Orbital ATK's Antares rocket. That'll be carrying the Cygnus OA-9E cargo ship, slated to fly on May the 19th from the Wallops Island spaceport on the Virginia mid-Atlantic coast. The next SpaceX Dragon cargo ship mission will be CRS-15 from Cape Canaveral on June the 28th. I'm Stuart Gary. You're listening to Space Time. A Chinese Long March 4C rocket has carried Beijing's new Gaofen 5 remote sensing satellite into orbit from the Taiyuan Satellite Launch Center in northern China's Jiangxi province. The Gaofen 5 is a high-resolution satellite, forming part of a near real-time, all-weather global surveillance network for security operations, as well as disaster relief, agricultural and environmental observations. The spacecraft is equipped with 6 payload instruments, including a visible and shortwave infra-hyperspectral camera, a visual and infrared multispectral imager, a greenhouse gas detector, an atmospheric environment infrared ultraspectral detector capable of very high spectral resolution, a differential absorption spectrometer for atmospheric trace gases, and a multi-angle polarization detector. The spacecraft was placed into a 635 by 662 kilometer high orbit and has a design lifespan of 8 years. Meanwhile, a Long March 3B rocket carrying the Apstar 6E telecommunications satellite is blasted into orbit from the Zhaichang Satellite Launch Center in Sichuan Province. Built by China Great Wall Industries, the 5-ton spacecraft is equipped with 26 C-band and 19 Ku and Ka-band transponders, providing satellite video and direct-to-home transmissions across the Asia-Pacific region with a design life of 15 years. You're listening to Space Time. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with a science report. Hot on the heels of reports that senior public servants want the Australian Signals Directorate to begin covertly collecting emails, bank records, text messages and all internet activities of Australian citizens without warrants, comes news that the Australian Bureau of Statistics has already been tracking the movement of Australians without their permission through their cell phones. The operation in and around Canberra in 2016 in partnership with Telstra collected hourly updates on users' locations and other personal information, including where they live. Telstra justified their part in the operation, claiming all the data provided to the ABS was anonymised so that no individuals could be identified. The ABS didn't even try to justify their actions, simply claiming that the project was within the law. A new study claims maintaining a healthy lifestyle, including eating a healthy diet, regular exercise and not smoking, could prolong your life expectancy at age 50 by 14 years for women and more than 12 years for men. The finding is reported in the American Heart Association's journal Circulation, based on data from 2 major ongoing studies that includes dietary, lifestyle and medical information on thousands of adults enrolled in the Nurses' Health Study and the Health Professionals Follow-Up Study. These data were then combined with National Health and Nutrition Examination Survey data, as well as mortality data from the CDC, the Centers for Disease Control and Prevention in Atlanta, to estimate the impact of lifestyle factors on life expectancy in the US population. Specifically, they looked at how a person's longevity was affected by 5 behavioral patterns: not smoking, eating a healthy diet, at least 30 minutes of regular exercise a day, keeping a healthy body weight, and moderate alcohol consumption. Compared with people who didn't follow any of the 5 healthy lifestyle habits, those that followed all 5 were 74% less likely to die during the follow-up period, 82% less likely to die from cardiovascular disease, and 65% less likely to die from cancer. There was a direct association between each individual's behavior and a reduced risk of premature death, with a combination of following all 5 lifestyle behaviors showing the most protection. An ancient Antarctic whale was all gums and teeth and no baleen, according to paleontologists who carefully examined the fossilized skull of the 8-meter-long giant. The specimen, reported in the journal Current Biology, is the second oldest baleen whale ever found, making it an ancient ancestor of baleen whales such as humpbacks and blue whales. But the big difference with this whale is the absence of baleen. Instead, the whale had large gums and teeth, most likely used to bite large prey. The findings suggest that large gums gradually became more complex over time, ultimately evolving into baleen. Scientists digging into the private lives of Australia's southern hairy-nosed wombats have revealed a host of secrets which should help breed the animals in captivity. One study looked at the animal's estrous cycle, which was found to vary between females. Taking urine samples could allow the stage of the cycle to be determined in captive animals non-invasively. The other study looked at mating behaviour. Scientists found that female wombats urinated less, paced more, and bit males on the bottom more often during their most fertile phase. The findings, which may also explain a lot in some other species, are reported in the Journal of Reproduction, Fertility and Development. A new pigeon species, named the Zealandian dove, has been identified at a fossil site in central Otago. Researchers say the pigeon, which is believed to be related to the Madagascan dodo, lived on New Zealand's South Island between 19 and 16 million years ago. It became extinct during a period of global cooling, which killed off many seed-bearing plants, possibly the pigeon's food source. The discovery is reported in the Journal of Paleontology and Evolution of Birds. Time now for another cure for baldness, and it seems the immunosuppressive drug cyclosporine also boosts hair growth. However, the findings reported in the journal PLOS Biology also warns that there are way too many side effects for it to also be a practical hair loss treatment. However, by combing through the molecular changes in hair follicles treated with the drug, researchers have managed to figure out the way they think it works, and they've found an alternative, safer compound which may well boost hair growth. Using real human hair follicles, they found this compound removes a molecular brake to increase hair growth. The next step will be clinical trials. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.